Thank you, Brian. It's great to be here today to share initial results from the Great Lakes Mass Marking Program with the Lake Michigan Committee. There's also a brief report out on the table outside for those interested in reading more about this. I'd like to start just by thanking everybody who's contributed to this project. It's a large-scale, multi-agency effort, and we couldn't be here today with these results without contributions from everybody. So just a very brief project history. The Great Lakes Mass Marking Program is a coordinated, basin-wide, multi-agency tagging and recovery effort that was requested by the CLC to enhance understanding of Great Lakes salmonines. Just a little bit about what we've been able to accomplish thus far. Tagging of lake trout began in 2010, followed by Chinook in 2011, and since the inception of the program, 16 million Chinook salmon have received a coated wire tag, as well as 28.5 million lake trout. Each of those have also received an adipose fin clip as an external mark. So we are now several years into this study, and we do have some initial results, in large part because we have 3 years of recovery data now. With regards to coated wire tags, over 50,000 snouts have been processed, with more than 46,000 coated wire tags recovered. The majority of those tags have come from Chinook salmon, as lake trout do take longer to recruit to the fishery, but we have started to see some lake trout tags trickle in, and those will continue to increase over the next couple of years. The key objectives of my talk today are to update the committee on the 2014 tagging and recovery activities, and then to highlight some of the preliminary analyses that we've done, which will cover 4 main themes: wild recruitment of Chinook salmon and lake trout, contributions of stocked Chinook salmon to the lake-wide Lake Michigan fishery, movement patterns of Chinook salmon, and information regarding other ongoing mass marking studies. So I'm going to continue to kind of revisit this slide throughout the presentation and just give you the bullet points followed by the supporting evidence. So the first one here is that the tagging and recovery operations are continuing to operate at full steam in Lakes Michigan and Huron. This is a table here of the number of Chinook salmon tagged by hatchery. You can see in 2014 we tagged a little over 2.9 million Chinook salmon, and the average tag retention at release was a little over almost 97%. We also estimate an additional 2% at-large tag loss. That's based on Chinook that were recovered that were lacking an adipose, that had an adipose fin clip but were lacking a coated wire tag. So overall, that amounts to about 95% tag retention by the time you get captured. That's pretty good, I think. We see very similar tag retention rates for lake trout. So now this is a summary of the lake trout tagged in 2014. A little over 6.4 million. And I will say these fish are not all going into Lake Michigan, but it's just kind of the program-wide tagging levels. And again, tag retention at release, around 96.4% for lake trout. We don't yet have a good estimate of at-large tag loss, but I would suspect it would likely be in the same ballpark of what we see for Chinook. And on a related note, we do have a side project coming out looking at tag retention rates from automatic tagged lake trout. That we do have some evidence that tag retention rates post-tagging take about 150 days to stabilize, and so that will help inform our efforts in the future as well. This is just a summary of the number of tagged fish per year by the program, and you can see once we started tagging the full cohort of Chinook, we've been right around 10 million fish per year. The declines in 2013 and 2014 are due to the reduced Chinook salmon stocking numbers. Our efficiency with tagging has also continued to go up, although it appears to have plateaued at a very respectable about 8,500 fish per hour in these automated trailers for both Chinook and lake trout. And then with a small kind of pilot program with Atlantic salmon that we do a very small amount of, that efficiency is also rapidly approaching that number as well. So the tagging operation is functioning very well. And the recovery operation, with the number of snouts and coated wire tags we've recovered, very happy with those numbers. There are technicians that are hired to work with each of the states. I have a map here of Lake Michigan and Lake Huron. We do also have 2 technicians that are assisting NYDEC on Lake Ontario. And on this map here, these red stars are the different duty stations. All of these blue circles are the ports that were sampled in 2014. So a pretty wide coverage there. It's a total of 42 ports, 31 of which were in Lake Michigan. These technicians, in addition to collecting the coated wire tags, are out there collecting a suite of biological data length and weight, as well as sex, maturity, lamprey wounding, and especially last year collecting tissues, muscle tissues for isotopic analysis, stomach samples, scales, and otoliths. They're out there trying to utilize these fish that we sample to the greatest extent possible. So a great effort on their part. And this is just a summary table from 2014. I've kind of bolded the totals here for each of the jurisdictions. I've separated out here on Michigan for the state of Michigan. But the bottom line here is in 2014, our teams looked at close to 22,000 salmonines, most of which were Chinook, right around 12,500, and lake trout, around 4,400. So a very substantial effort that goes into this. One thing I do want to mention is even though they're not targeted species, our teams are still seeing substantial amounts of steelhead and coho, so that does bode well should mass marking continue on to other species in the future. So that's a summary of tagging and recovery operations. I'm going to jump right into some of the early results now. And the first main result that I'm going to present is evidence of wild lake trout recruitment in both Lake Huron and in southern Lake Michigan. Chuck Medengian did a great job of talking about that before the break. And this is just going to highlight the mass marking data that he mentioned in his talk. So we calculated the percent of lake trout recovered in 2014 that had no fin clip. And in this particular map, I've just grouped the values by latitude. So we have a southern portion of Lake Michigan, and so for these statistical districts, we had an average of 21.6% that were lacking a fin clip. In the middle of the lake, these 4 districts, that average is 14%, and then in the northern, an average is 7.9%. And as you saw with Chuck's talk, these numbers are very similar to what's being observed in both the spring LWAP surveys and especially the fall spawning surveys. Just as an aside, we are seeing in Lake Huron an average of a little over 50% of the lake trout coming in without a fin clip, substantiating some of the results there for the resurgence in lake trout. I do have a biplot here now for looking at this latitudinal trend in unclipped lake trout from the angler return data to mass marking. These are biotechnician collected fish from anglers, and so latitude here is on the x-axis with south going to north, and this is the percent of trout without a fin clip in each statistical district. So each of these points represents the average value from a statistical district. The latitude values are from the centroid of that district. So you can see that very strong negative relationship. Latitude is explaining close to 58% of the variance in these data. So these 4 points here, that southern district, these are the kind of the middle districts, and these are the northern districts. So this is consistent with what we know about lamprey densities in the north versus the south of the lake, as well as catch in various fishing efforts. So with that, I'm going to move on to results for wild recruitment of Chinook, and the evidence we have is of a weak 2013 wild Chinook year class, particularly in northern Lake Michigan. So the first table I'm showing here is the percent unclipped Chinook for all of the age classes recovered in 2014. And so if you consider all fish, we do see about what we've seen in previous years, close to 60% unclipped in Lake Michigan, 55% in Lake Huron. If we look specifically at the 2013 year class at age 1, however, our estimate for Lake Michigan is about 37.4% of those fish being wild, and that's that percentage is based on a reduced stocking number. So if we look at this figure here, this is the percent wild estimates over time dating back to 2006. And so if we just compare this with kind of 2011 and 2012, we're around 55-60%, and now we're dropping to 37%, but relative to the stocking numbers in 2012, that's actually closer to about 18 or 19%. So unfortunately, a weak year class of wild recruitment, although as Randy Claremont's going to show in the next talk with the PPR model, that is is coinciding with low numbers of alewife, which isn't necessarily a bad thing with respect to the predator-prey ratio model. So just a little more detail on the percent wild here for the age 1 year class. I compared the statistical district values for percent wild at age 1 to the overall all age class values. And so these yellow highlighted districts are the ones where the confidence intervals didn't overlap. In other words, there was significantly more percent wild from all age classes than from age 1. In the southern part of the lake, we actually saw a reasonable percent wild at age 1 for the 2013 year class. And this is just showing these data in another way with, again, latitude from south to north. The age 1 year class from 2013 are the black points in this line here. Again, a substantial negative relationship that we don't see when we look at those from all age classes. That's these data points here in the light gray. So several contributing factors to this. It seems to me and to other people I've talked with that this is likely some sort of anomaly based on environmental conditions. So for example, I've talked to a number of folks that are saying that in 2012 during that spawning run there were very low water levels as well as warm water temperatures that could have negatively affected the spawning run and the wild recruitment of those 2013 year class. In addition, everybody likely remembers the very harsh winter that you guys had shortly before I moved back to the Midwest. Lucked out on that one. That's definitely reducing the growth rate of the Chinook salmon for this year class. If we look at the known age fish, the growth rates are reduced for those known age fish compared to last year, and so it's potentially that is affecting survival to some extent. And then on top of that, low production of young year alewife in 2013. All three of these things could be contributing to the weak year class that we observed. One other possibility is if there is in fact reduced growth rates, it's possible that's reducing catchability to the fishery. So we are going to be taking a very careful look at this year class in the upcoming summer to see if we see kind of weak numbers for age 2s this year. I don't think that's what's going on because we did see similarly low growth rates in 2011 and yet still had a high estimate of wild recruitment. So we'll also be really interested to see this summer whether our age 1 wild recruitment numbers bounce back. All right, moving down the line here, from the coated wire tag returns, we also have some very intriguing evidence that post-stocking survival of Chinook salmon appears to be greatest on the western shore of Lake Michigan. So just really briefly, we went about this analysis by looking at the contribution of stocked salmon to the fishery, and we're considering this to be a proxy for post-stocking survival. At each of the statistical districts where we recovered fish, we summed those to the recovery district, and then computed the number of recoveries coming from each of the various stocking statistical districts, correcting for number of fish stocked. And then because there's possible difference in biotechnician effort, sampling effort between the districts, we converted these to a percentage estimate where we're looking at the percentage of fish from each stocking district that was recovered in each recovery district. I just have a very small excerpt from our data table just to kind of show exactly what I mean here. So we have rows for each of the stocking district. That's the district where the Chinook were stocked. And then in each of the various districts, we said, okay, in Illinois, 8.5% of the fish recovered in the Illinois district were stocked in Indiana. 5.1% of those recovered in MM8 were stocked in Indiana, and down the line for each of those districts. And so then by analyzing these percentages, we're removing bias that would be associated with any potential differences in sampling. And the next slide is going to present these results from a single factor ANOVA, looking at the effect of stocking district with Tukey-Kramer procedure for post-hoc pairwise comparison. So I'm not going to show a table with all of the T and P values. Rather, these color codes represent the pairwise significant differences. So just to kind of orient you to this figure, the statistical districts here on the x-axis, these two over here were coded wire tags that were stocked throughout Lake Michigan and throughout Lake Huron in 2011, so we don't actually know the statistical district is stocking for these two groups, but these are all known to a specific district. And then this is the average percent of recoveries per 100,000 stocked. The blue group had significantly higher contribution to the fishery compared to both the red group and the white group, whereas the yellow group was significantly higher than the red group only. So now that you're oriented to those color codes, the easiest way to visualize this is to look at this on a map. And so we see that those blue groups and those yellow groups are occurring here on the western shore of the lake. The red groups where we had kind of poor contribution to the fishery, primarily coming from Green Bay, and two of the districts on the eastern shore of the lake. So we've been thinking about what might be causing this. I've talked with a number of people here at the meeting, and we've kind of brainstormed a list of ideas. We don't know the mechanism, but we do have some hypotheses. One thing we know is that there's greater upwelling events on their western shore, so there might be colder water temperatures that are more suitable. In talking with both Dave Warner and Chuck Medengian from the Acoustic Prey Fish Survey and the bottom trawls, they said that anecdotally, generally when they get a large catch of alewife, it is coming from the western side of the lake, so there may be some differences in forage. And someone else also brought up the possibility that with the prevailing westerly winds, there may be more infall of terrestrial ants and invertebrates that could be providing an important food source for these young of year and age 1 Chinook salmon. So again, we don't know what's contributing to this pattern, but it is a pattern that we see consistently, and we're going to see it again in the next group of slides, where I'm going to be focusing on lake-wide mixing of Chinook salmon during the foraging season. So the coded wire tag returns that we see do show substantial movement and mixing of the Chinook salmon. I'm going to show you a series of figures, and to orient you to these, each of these figures is showing for a given port, so in this case Sturgeon Bay, indicated by the star, the recoveries per 100,000 fish stocked from each of the various stocking districts. The two blue dots represent those lake-wide coded wire tags that I mentioned earlier. So we're actually going to be focusing on these red dots where we actually know the stocking district. And so the interpretation of this particular figure is for fish landed at Sturgeon Bay, Wisconsin, these dots with their size is proportional to the number of recoveries. So the two main things that I want you to see from each of the maps I'm about to show is, one, we have substantial contributions from throughout the lake and from Huron to most of these Lake Michigan ports, and two, you're going to usually see these larger circles on the western side of the lake. On top of that, I'm not going to focus very much on these pie charts, but what these show are the percentage stocked in the resident district. So for Sturgeon Bay, that's actually WM1 and WM3 combined, and then summarized by the distance away from that stocking district, with lighter blue indicating a further distance. But again, I'm going to cycle through these quickly. I'd rather focus on these maps. So we're going to move down around the bend of the lake and back up. So as we move south, you see a very similar map for Port Washington. In fact, the only thing that's really changing is the location of the port. This is North Point Marina in Illinois. Again, very similar pattern. We're rounding the bend now. Here's Michigan City, a very similar pattern. And even as we move back up the eastern side of the lake, here's South Haven, Michigan. You can see large circles on the west, smaller circles on the east, and again, very much mixing. Same with Frankfort, Michigan. I could show you a bunch of these. We have these maps available upon request. So I know we have one for Ludington. It would show the same thing. So very consistent and does support this notion that there's potentially something going on with better survival on the western shore. There are a few exceptions to these maps. Actually, Manistee is not an exception. That's kind of showing the same thing. I forgot that one was in there. But with Traverse City, we do see more locally sourced fish being captured in Traverse City. I should have prefaced that all these maps are from the open water fishery, so no weird data or anything. These are all open water angler returns. If we go over into Lake Huron, primarily those fish are coming from Lake Huron for both Sheboygan and Rogers City, with smaller contributions from Lake Michigan. So, which actually brings me to the next point here. Chinook salmon stocked in Lake Huron are feeding in Lake Michigan. That's something that Rick Clark has been spearheading for a while. We're going to be working with him with the mass marking data as well, and it's going to be mentioned in the upcoming talk with Randy Claremont. With regards to the mass marking data, if we look from April to August, which is what we're calling the feeding season, close to 89% of the fish that were stocked in Lake Huron were actually recovered in Lake Michigan. The inverse of that, only 0.3% of fish stocked in Lake Michigan were recovered in Lake Huron. So this seems to be a very unidirectional movement from Huron to Michigan. And I will mention that the values are very similar if we look at age 1 fish only, which is important for informing the PPR model. So on top of that, if we look at this from the Lake Michigan perspective, 11% of the fish recovered in Lake Michigan from 2012 to 2014 were stocked in Lake Huron. So this is more than just a drop in a bucket. We're talking about a somewhat substantial contribution to the Lake Michigan fishery from Huron stocked salmon. All right, so you can see I'm running out of room in my take-home point slides. I got 2 more to go. Chinook travel great distances, but have high fidelity to the stocking district in autumn. So we do have cool data coming out again from the tag returns that show both of these things. What I'm going to show is now is a series of 3 figures for the 2011 year class. I've done these for the 2012 and 2013 year class as well. They look very similar, but I kind of wanted to highlight the differences from age 1, 2, and 3. So on these figures, I've got the distance between the stocking district and the recovery district in kilometers, and that's kind of a very conservative estimate of distance moved, because this is a straight line distance from the centroids of the stocking and recovery district, and of course that salmon is not just swimming on a straight line. So, we also have the frequency here on the y-axis. In all of these, for all these age classes, the mean value is right around 140 kilometers, and you will see that modal value here for age 1. But what I want you to notice is this very long right tail extending from 200 all the way out to 500 kilometers, so we are seeing substantial mixing of these fish. One interesting pattern, as the fish get older, this box, which is the fish recovered in the district of stocking, does increase. So here we are at age 1, and we see that that's right around 60 and is somewhat low compared to the rest of these values. At age 2, it's still low compared to these values, but you can see that frequency has crept up. But we still have this long right tail. And again, at age 3, even more so, coming to the district of stocking with, again, a right tail. Now, for these particular figures, this is recoveries from every time of the year. Again, they're only open water, but it is considering stuff from the early season as well as the late season. So we actually broke down this pattern by month for the 2011 year class, and we do see a very strong seasonal pattern. So for age 1, 2, and 3, from April through July, we consistently see only about 10% of the Chinook salmon recovered in the district where they were stocked. August appears to be a transitional month, particularly for ages 2 and 3. Here we're up to about 20% for the age 2s being recovered from the district of stocking, and about 30% for age 3s. And by the time we get to fall, September and October, even if we're looking at age 1s, we are seeing about 70% of those recovered are coming from the district where they were stocked. September and October for age 2s are around 50 and again 70%. And then age 3s, the really mature fish, in September were over 80%, in October were over 90%. So again, these are open water recoveries, no weird data. It does show that there is some staging that takes place that is affecting where these Chinook salmon are caught and being harvested from the fishery. So with that, that's the information I have for results for the time being, but I do want to highlight some of the ongoing work going on with mass marking. One thing in particular that we started collecting last year are muscle tissues for a stable isotopic analysis of Lake Michigan Salmonines. We're collaborating with Bo Bunnell from the USGS on this project, and the goal is to determine the trophic positions and primary energy sources of Chinook, lake trout, coho salmon, brown trout, and steelhead in Lake Michigan. And this in particular we're hoping this will help address a Lake Michigan research priority regarding the species-specific forage demands of the Lake Michigan salmonine community. The stable isotopes, we're going to be looking at carbon and nitrogen. One key objective would be examining diet overlap among the species. This is going to be especially timely given the evidence that we've shown and that Chuck Medengian showed about positive signs for lake trout recovery in the lake. So that's one key objective. We also collected these tissues from 2 different size classes per species and at the 4 intercardinal regions of the lake, so northwest, northeast, southwest, southeast. So if there are size or region-specific patterns, we hope to be able to identify those. On top of that, we had different collections for stocked and wild lake trout and Chinook salmon. So if there are differences between stocked and wild fish, we can identify those. And for the stocked fish, depending on how the coded wire tag information falls out, we may be able to do some information with regards to Chinook salmon age as well. And then down the line, we're interested in comparing salmonine trophic position amongst the other lakes. Here I just highlight Lake Michigan with the somewhat more relatively intact Lake Superior food web, but I know that the Ontario Ministry of Natural Resources and Forestry, out of Tim Johnson's group, is putting together a similar analysis for Lake Ontario. So we're going to be really curious to see how these salmonines fall out across lakes and compare and contrast any similarities or differences. I'm pleased to report, too, that these tissue collections in 2014 are just about ready to be sent out for analysis. With that, last slide, thank you for bearing with me. We're also, as I already mentioned, working with Rick Clark from MSU and his group to do a more detailed assessment of salmon movement from Huron into Lake Michigan. One thing that we're getting started this summer that I'm really excited about is working with Dominic Shaloner and Gary Lamberti's lab out of Notre Dame, as well as a PhD student, Brandon Gehrig, and then Rick Radisky from Grand Valley State. We're going to be looking at how energy source and trophic position determined by stable isotopes interact to influence contaminant accumulation in salmonines. We're doing mercury for sure. We're out there trying to get some funding to look at PCBs and organic contaminants as well. So something exciting that will be coming out down the line. We're also working with the Lake Michigan Lake Trout Working Group to look at factors that affect post-stocking survival of lake trout. This will be an analysis of the spring LWAP surveys from 1998 through the present, looking at the fractional coded wire tags. We don't have enough recoveries from mass-marked lake trout yet, but we do have recoveries from the fractional tags that happened in lake trout through about the mid-2000s. So that's what this analysis will focus on. Again, a multi-agency collaboration with the working group. I already kind of mentioned this, looking at tag retention in the automated lake trout by an automated system. And then finally, this particular talk we are presenting in a special session organized by our colleague Dmitry Gorsky from the Lower Lakes Lab. That special session at AGLR is going to be looking at the use of tags for monitoring movement and habitat use of aquatic species. So we'll be sharing these results at that forum and at the National AFS meeting as well. So with that, I don't have a formal acknowledgement slide, but there are a ton of people not mentioned, all of the hatchery folks and the fin clippers that help with the tagging operation, the biotechnicians for recovery. So thanks once again to everybody who contributed to this effort. And if there's time, I'll take questions.